let me comment. I'm not going to do one, but another place where something like that can happen, or another way that could happen where you have to square both sides. We aren't going to work this one in total, but I do want to kind of put it in there as a hint. If I gave you a sine of x equals a cosine of a half angle, okay, you would have to go get the cosine half angle formula. Yeah. Which the half angle formulas have what in them usually? That's the ugly square root ones. Oh, you can do it. But yeah, okay. The first thing you'd have to do would be square both sides, so you get rid of the square root. So there's going to be another one you have to check because you're going to square both sides to get rid of the square root. I will give you yes, I'll give you those identities, yes. So you would just, it actually isn't that horrible. We're not going to work this all the way, but it would make you have a sine squared, and you would just get rid of the square root. So then you'd be back to a normal problem. You'd have to times 2 over so that you got rid of the fraction, and then you could change sine squared into 1 minus cosine squared and be all cosines, and it works like a normal problem. But you would have to check this one at the end because you squared both sides. And you would check it in the original problem, not after you squared it. So. Shoot it now. Okay. Well, now it wants to work. Well, it worked for a moment.
Maybe the eraser works. Try the eraser again. See if that works.
I have a theory. I think my theory's wrong too, but maybe not. Maybe not. I found non-rechargeable battery, but regular 4A battery to put in this other pin, so it will wear out the battery. But I wondered if it's just that this pen isn't charging anymore. If that's my issue. Okay, but anyhow, I was about to write. Well, nope, it's still frozen. So maybe it's. Or hold, I didn't mix my pens, did I?
And you forgot to pause the video.
I know. I can't pause the video because I can't get the pen to work. Okay. Your board is disconnected. It is? Oh, there it goes. Yep.
Technology is failing us.
Yes, technology is failing. Okay, so now that we're playing again, yes, you're going to check your answers in the original problem, but I actually want to go to the other kind of problem you're going to see today. This is actually quite easy if you see it coming at you, but oh my heavens. I have lots of people who don't see this one coming at them, and they try to do this. I'm actually going to tell you for once, don't work it with identities. I have people try to work this with identities and get in the biggest algebraic nightmare of their lives. So, we will see if I can get you to not notice that. We'll start with medium and move up to tricky. Okay, so if I give you 2 times the tangent of a half angle plus the square root of 3 equals a negative tangent of half angle x.
What did it say? Yeah.
Okay, what I want you to notice is, are those all tangents?
Yeah.
Yes.
Are they all the same angle?
Yeah.
So therefore, you don't have to do identities. If it's all same trig function, all same angle, we're just going to solve for that half angle. We don't have to sub in identities. Because subbing in those half angle identities, they're ugly identities. We don't want to use the half angle identities. Yeah, we just need to combine our tangents. This is just solve for tangent. So yes, I could add a tangent over here. So, well, you could. You want to subtract it?
No.
Some people like their tangents positive. Sorry. Not again. Okay, so 3 tangent of half angle. Actually, if it's okay with you, I'm going to toss the square root of 3 over on the other side. What do I have to do to solve a tangent? Devin, you're missing this. And therefore, Shannon's missing this. So, I don't even have to go that far. Divide by 3. I just want to get tangent by itself. Because if that was tangent x, you wouldn't think a thing about it. If it was tangent x, you go, oh, it's all for tangent. And we got negative square root of 3 over 3, which, that's special. We are in radians on this one. Okay, so you're going, yeah, that's good. I got a special angle value. Okay, but the wrinkle is, back here on every problem we've done before, we were solving for angle x. We got it so every problem was down to x's. Every problem you've done, you add it back down to angle x. Okay, I'm now solving for angle half x.
Can you make it a whole?
Well, at the very end, we make it a whole. Because I don't want to use the identities on this. The identities will make this messy. I just want to solve for angle half of x.
So then
And then at the end, yeah, I'll times by 2 and get solve for x. So what? Just normal. Where's tangent? Negative. What quadrant? Second and fourth. Where's it? Square root of 3 over 3. We're in radians this time, so pi over 6. Okay, so I would have that. But here's the wrinkle to it, which actually, when it's a half angle, this is a good wrinkle. This interval I gave you, that's the interval for angle x. So what's the angle for half of x? What interval? If I have to do half of it, I have to do my interval in half. That would reduce this to 0 to pi. So I can only have answers then for this half angle between 0 and pi, which means I can only have answers in what quadrants? 1 and 2. So I can't have this fourth quadrant angle. I can only have answers in quadrants 1 and 2, so that means I have one answer. Which is what? 5 pi over 6. Yeah. Then you're going to go ahead and go and solve for x, though. How do you solve for x? You're going to times by 2. And so we're going to get 5 pi over 3. And on this particular one, you only get the one answer then. So half angle problems that have entire half angles in them usually don't have very many answers.
Can you don't want to change the and become a whole
Well, we did, actually. Okay, that's a good question. Simone's going, but if I times it by 2 and I solve for x, wouldn't I be back to the 0 to 2 pi? Well, 5 pi over 3 is actually a fourth quadrant angle. That is an answer between 0 and 2 pi. And that it'll automatically happen. So we actually got it right there, because this 5 pi over 3 would be in the fourth quadrant. So that really did convert then back to being an answer between 0 and 2 pi. See? So let's do it. That was fun. That was like, you like the half angle ones because it cuts your answers down. You get less answers. But I have one more for you. It's good. You'll love it. You're going to be excited to see this. And our answers on this one are going to be between 0 and 360. We're doing degrees this time. So, what do you notice about the angle?
we have a triple angle.
We have a triple angle, yes. So therefore, but you'll notice, the entire problem is all the same trig function at all the same angle. So to do this, it has to be, that's important. If it's not the same trig function and not the same angle, you cannot do this. You'd have to go use identities. And in this case, we don't really have, all right, the identities we'd have to use to do 3 theta. We'd have to do the a plus b identities to do 3 theta. It would be like a, I don't even want to think about what a horrible nightmare it would be if you tried to solve this by identities. So that's really, really, really critical, though, that it has to be all the same trig function, all the same angle. we could factor it, because since it's all the same trig function, I just need to solve for this cosine of 3 theta. So, it's a trinomial, you think it'll factor?
Yeah.
Yeah. I think it'll factor. 2 and 1, I'll make 3 in the middle. I think we're good. So yeah, working these kinds should not be a big deal. It's just noticing that you can do this. That's where we tend to miss it. Okay, because it's got to be 2 and 1, and the ends have to be plus 1s because everything's positive. Does that make 3 cosine in the middle? Yeah. Yes, it does. All right, so this part's easy, no big deal. So if I solve each factor, I'm going to get cosine of 3 theta equals what? Nicely yawned. Negative 1/2. And then cosine of 3 theta equals negative 1. So that's good news, special angle values, we like it. Okay, but what angle are you out to solve for? When we start producing angles as answers, what angle are we solving for?
3 theta.
We are solving for 3 theta here. We are not solving for the single angle, we're solving for the triple angle. Okay, actually I should have written that lower because I'm going to need space. Okay, so I need to know, you can, but hurry back because there's about to be a huge wrinkle right here.
Cosine's negative in 2 and 3.
Cosine is negative in 2 and 3. All right, cosine equals a half where? We're in degrees. Yep, that's 60. Or if we were in radians, it'd be pi over 3, but we're in degrees, so it's 60. So that gives me answers of 120 and 240. Okay, that wasn't bad at all. That was pretty tolerable. But what did I have to do on the last problem? Times what by 3? Yeah, the interval. This is the big wrinkle. If this theta was between 0 and 360, we have times it all by 3. So that means it can be between 0 and 1080, or in other words, it means you can go around the circle 3 times.
So we just add like 3.
So yeah, actually all you have to do, it's going to be, if we go around 3 times, it's just these same angles, but if this one was at 120, what do I get when I go around and stop there again? Yeah, just add 360 on. So if I add 360 on to 120, if I add 360, that's going to be 480. And you might as well do it again. We got to go around a third time, so add another 360 onto that. 840, wouldn't it? Okay.
The other one would be 600.
Okay, so if I add 360, that one will be 600 and
And then
960. So that's all the answers for 3 theta. What do you have to do to get the final answer for just plain old angle theta?
divide by 3.
You got to divide all your answers by 3 then.
So 40.
So yeah, so 40, 80, 160, 200. Divide that by 3. 280
280. Yep. And the other one is 320.
and 320. And notice, your answers then should all be between 0 and 360. And they are all back between 0 and 360. So, it's kind of cool. Oh, shoot, you're right. Darn. Sorry, don't uncircle that. You're right. Whoa, I forgot we have another set of answers to go. We got to do 3 theta here. Where does it equal negative 1 at? This will be less answers, fortunately. Okay, if it's a 1, it's on the quadrant line. Cosine's positive 1 at 0. So it's negative 1 at 180. So it would be 180 would have been another answer, and I would have had to add 360 on each of those two, which would be 540 and 540, I didn't write big enough. And another 360 would be 900, yeah. And then I would have divided all those by 3 too, so I would have also gotten 60, 180, and 300.
What is that for?
We hadn't solved this one. So you had one more answer, you had 180, and you had to go around as well with that. So in this case, yes, 9 answers. It's a rare occasion when you'll ever see that many answers. 9 answers.
We won't have one like this on the test, will we? Any questions?
I know. There will be something.
If you want to stop.
Yeah, I will, thank you.
Not with like